Good evening everyone, myself Shaptapurni from BioLive. Hope all of you are doing very well. So today I am going to teach you about Anova, one-way Anova, how to solve the one-way Anova. Okay, so before beginning I would like to request you to kindly subscribe to my channel by pressing the bell button given below, and if you like this video don't forget to hit the like button and share it with your friends. Okay, and if you have any doubts don't hesitate to leave a comment below. You can also find videos like linear regression, how to solve linear regression in your scientific calculator like FX991MS or FX82MS. Okay, the links are given in the description box below. So okay, this is your Anova table. Okay, not Anova table, your data table. They will give you this table in the examination and you will ask to do the one-way Anova and to justify something. Okay, so in this table you can find that there are 4 different groups based on 4 different diet types. Okay, this is the feed 1 group, feed 2 group, feed 3 group and feed 4 group. Total 19 pigs are there which are experimentally divided into 4 different groups. Okay, see, in the first group, second group and third group, fourth group, there are total 5 into 3, that means 15 pigs, and in the third group there are 4 pigs, so 19, total 19 pigs are there. So they are asking you that these are the body weight of those different pigs, okay, raised on different diets. So they are asking you if there is any significant effect of these 4 different diets on the body weight of different pigs, okay, on the body weight of pigs, and you have to justify that by calculating the Anova, okay, by solving the one-way Anova. So the question asks you, this is the question: 19 pigs are assigned at random among 4 experimental groups. Each group is fed with a different diet. The data are pig body weight in kg after being raised on these diets. Applying one-way Anova, justify whether pig weights are same for all the 4 diets or not. Okay, so to solve these, first of all we need to write down the table in the paper. Okay, and after that we need to solve some formulas like this. See, what is I? I is the number of groups. Okay, this is the number 1 group, number 2, number 3, number 4. What is Ni? Ni is the number of samples in each group. For example, in the first group there is 5 samples, in the second group 5 samples, in the third group 4 samples, in the fourth group 5 samples. Okay. Now what is summation of Xij? Xij is the summation of total number of samples. Okay, summation of all the samples present in each group. So this is the 323.1, which is the summation of all these numbers present in the first group. This is the 356.5, this is the summation of all these numbers present in the feed 2 group. Okay, now coming to the Xi bar. Xi bar is nothing but the average of all the sample values present in each group. Okay, so Xi bar can be found by dividing this number by this number. Okay, that means 64.62 is the average of the value present in feed 1 group. Okay, like that, how can you get the 71.3 value? By dividing 356.5 value by 5. Okay, so just divide the summation of each group by the total number of sample present in that group and you will get the average value. So like that we have got these average values. Okay, now coming to the next thing, summation of Xij. Summation of Xij, and this is the summation of whole population. That means it accounts for all summation of all of these numbers. Okay, so during examination it becomes very difficult to add up all these numbers one by one, so you can just add up these 4 numbers. Okay, because these 4 numbers are actually addition of each group. Okay, so just add up these 4 numbers and you will get the total summation value. Okay, now this is the population mean. Okay, that means the total value, the total addition value or the summation divided by total number of samples present in the population. here n equal to 19. Okay, total number of samples or the sample size of the pig population is 19. So just divide 1289.2 divided by 19 and you will find the population mean 67.85. So first of all, after getting the Anova table, you have to after getting the data table, you have to solve this table. Okay, after solving this table, we will solve some other equations, okay, where we will use these formulas like summation xi bar, x bar, these are, okay. So let's take a look on that. So okay, next we have to find out total S's. Total S's means the summation of summation of squared mean, okay, where we have to subtract the x bar or the population mean from each sample value. Okay, see how does that come? See here, we have to subtract the population mean. What is our population mean? We have got that our population mean was like 67.85. okay, so you have to subtract 67.85 from each value. So subtract 67.85 from 60.8, then square that one, and then subtract 67.85 from the next value 67, and like that do just subtract 67.85 from all of these values, okay, all of these values, okay, till the last one. And after that, when you are subtracting from all of these values, just square those up and write your value here. That will be your total S's. Okay. Now coming to the total DF. Total DF means the total sample size. That is our in this case 19 minus 1. That is total DF will be your 18. Okay. So coming to the next thing, that is our group S's. What is group S's? After doing the total S's, you have to find out the group S's. In the group S's, you have to do the same thing, but here you have to subtract the population mean from the mean of each group, okay, and then you have to multiply that one by the number of samples present in each group. Okay, so here see, in the first group there are 5 samples, and you have to subtract population mean 67.85 from the mean of the first group, that was 64.62. See here, the population, the group mean of first group was 64.62, and square up that. Like that do for the all of the groups, okay, and you will get the group S's. Now for group DF, you have to subtract 1 from the number of groups. So here the number of group is 4, so subtract 1 and you will find the value as 3. Okay, so group DF is 3. So now we have got the total S's and total DF, along with that group S's and group DF. Next you have to find out the within group or error S's. So error S's is nothing but the total S's minus group S's. Okay, so just subtract group S's from total S's and you will get the value of error S's. And similarly, to find out the error DF or within group DF, you can just subtract group DF from total DF, that is 18 minus 3, and you will find the error DF as 15. Okay, this is another formula, you can also use that one, but I think it will be easier. Okay, just subtract group DF from total DF. Now you have got everything like values for total S's, total DF, group S's, group DF, error S's and error DF. And now you have to form a Anova table, and before that you have to find out some other things like error MS and group MS. Okay, so see, before that we will construct our null hypothesis and alternative hypothesis. So our null hypothesis, that is H naught, says that the mean weight of all pigs are equal. That means there is no effect of different diets on the weight of pigs. Okay, so mean weight of all pigs are equal, so mu1 equal to mu2 equal to mu3 equal to mu4, where mu means the mean weight of each group. Okay, Whereas alternative hypothesis says that mu1 not equal to mu2, not equal to mu3 or not equal to mu4. That means the mean weight of pigs at different feed groups or different diet groups are not equal. Okay, that is our alternative hypothesis. So now for testing our hypothesis, we need to find out the group MS. Group MS is nothing but the division of group SS by group DF. Okay, so just put the values of those two and you will get the value of group MS. Similarly, to find out the error MS, just divide error SS by error DF and you will find the value of error MS. Now you need to find out the value of F, the F statistics. The value of F is group MS by error MS. Okay, just divide group MS by error MS and you will find the value of F statistics. Now, if your problem is following the null hypothesis or not, you have to solve that by seeing this number, okay, by observing this F value. If this F value is lesser than or equal to the critical F value or table F value, then your problem is going with the null hypothesis, and if this F value, your calculated F value is greater than your critical F value or table F value, then the problem is not going with the null hypothesis, it is accepting the alternative hypothesis. Okay, this is the main thing behind this ANOVA. So now you just need to draw an ANOVA table. Okay, this is the summary table of ANOVA, where you have to write down the source of variation like total, group and error, their SS, DF and MS value. Obviously there will be SS for everyone, DF for everyone, but there will be MS for only group and error. Okay, and the F value. Now you have to find out the critical F value. The critical F value will be given in your problem. See here, the critical F value at alpha 0.05. Okay, level of significance is 0.05. For one tail test, the DF will be K minus 1. K minus 1, what is this? This is our group DF. And another DF is N minus K. What is this? This is our error DF. Okay, so F value, critical F value for alpha equal to 0.05 at one tail test for DF3 and 15 is given as 3.29, which is lesser than your calculated F value 12.045. This is your calculated F value, okay, and your critical F value is 3.29. So obviously critical F value is lesser than your calculated F value. So obviously you can easily say that your problem is not following the null hypothesis, rather it is following the alternative hypothesis. So how should you write that? Write that like this: since the calculated F value, your calculated F value is 12.045, is greater than the critical F value or table F value, which is 3.29 at P equal to 0.05 or alpha equal to 0.05 for one tail test, at DF3 and 15, the null hypothesis is rejected as it is greater. Okay, so null hypothesis is rejected, indicating that different food types bear unequal effects on the mean body weight of the pigs. Okay, that means there is some effect of different food types on the body weight of pigs. Okay, that means mu1 is not equal to mu2 is not equal to mu3 is not equal to mu4. So null hypothesis is rejected, whereas alternative hypothesis is accepted here. Okay, so this is all about how to solve your one-way ANOVA problem. I hope this video will be useful for you. Thanks for watching and happy learning.